In this question we are given that there is 50 pounds of bananas on a display table in a certain grocery store, and that the customers remove bananas from that table at this rate, which is given by this function, for a time between 0 and 12, and that store employers add bananas to the display at this rate, but not starting from time 0, but starting from time t equals 3. And the question is how many pounds of bananas are removed from the display table during the first 2 hours when the store is open. And so this is just integral from 0 to 2 f of t dt, because this is the rate at which it's being removed. So it's integral from 0 to 2, 10 plus 0.8 t sine t cubed over 100, close parentheses, dt. So let's use a calculator to calculate this value. Let's find this integral now, and this is mathematics, integral from 0 to 2 of the function f of t, which is 10 plus 0.8 times x times sine of, in parentheses, x cubed divided by 100, and again it doesn't matter here whether we have close parentheses, whether we have t or x in this case, and so dx is our variable, and let's calculate it. And so we have 20.051, which is the number of pounds of bananas that are removed from the display table during the first 2 hours of this, that the store is open. In this question we are being asked to find f prime of 7, which is the rate of change of the rate at which the bananas are being removed from the table. So we just need to find the derivative of f with respect to t at time equals 7, and let's use the calculator to do that. So let's find the derivative of this function f at the time t equals 7. So let's go to mathematics, derivatives, with respect to the variable x of the function t, f of t, which is 10 plus 0.8 times x times sine of the variable x cubed divided by 100, close parentheses, at the point x equal to 7. Let's evaluate that, and we get that negative 1.20, so which means that after the store has been open for 7 hours, the rate at which bananas are being removed from the display table is decreasing by 8.12 hundredths, and the units are pounds per hour per hour. The rate itself is pounds per hour, and this is the change in the rate of the removal, so it's pounds per hour per hour. In this question we are being asked whether the number of pounds of bananas on the display are increasing or decreasing at time t equals 5. And so what we are really being asked is whether g of t minus f of t at t equals 5, whether this is greater than or equal to 0, or greater than 0 or less than 0. So g of t is the rate at which the bananas are added to the table, and f of t is the rate at which they are taken from the table. So if it's increasing, if this is number greater than 0, then it's increasing, otherwise it's decreasing. So we need to calculate this number at t equals 5, and we do that with a calculator. So let's calculate g of 5 minus f of 5 here. And so g of 5, let's plug in the number 5 plus 2.4 times natural log of t squared, which will be 5 squared, plus 2 times 5, we are plugging in 5 instead, minus 10 minus 0.8 times 5 times sine 5 cubed divided by 100, close parentheses. So we calculate that, and we get negative 263 thousandths, which is less than 0, which means that the number of pounds of bananas on the display table is decreasing at time t equals 5. So the answer is it is decreasing. In this question, we are being asked how many pounds of bananas are on the display table at time t equals 8. And so this is the number at time 0, plus all the bananas that have been added. And in this case, this is between 3 and 8, because the bananas are not being added between time 0 and 3. And so this is g of t dt, minus all the bananas that have been taken out between time 0 and 8, f of t dt. And we just need to calculate that using the calculator, using these two functions in the calculation, and let's do that next. So let's calculate this expression here, which is 50, the initial amount of bananas, plus integral at which bananas have been added from 3 to 8 of the function g of t, which is 3 plus 2.4 times natural log of t squared, x squared, plus 2 times x, close parentheses, dx, and then another integral minus, and now we have another integral, the rate at which the bananas have been taken out from that table, from 0 to 8 of the function 10 plus 0.8 times x times sine of x cubed divided by 100, close parentheses, and this is also with respect to x. So let's calculate this entire expression, and we get the answer 23.347 thousandths, which is the amount of bananas in pounds that are on the display table at the time t equals 8. 23.347 thousandths. Thank you, and I will see you in the next video.